Hi guys, this is the South County Web Tutor, and I'm here doing the CLEP College Algebra video series, and I'm now on section 1.3, polynomials. Okay, so let's talk about polynomials. What are they? Okay, polynomials turn out to be algebraic expressions like we learned last time, that are added or subtracted to each other. Okay, they are made up of what we call terms. Alright, so here's an example of a polynomial. 2x squared plus 3x plus 1. Okay, that is an example of a polynomials. They are made up of terms. So terms are each individual part of the polynomials. Okay, so let's talk about what these terms can and cannot be. Okay, not a polynomial term. Okay, things that are not polynomial terms. Okay, polynomial terms, this has to do with their variables. Okay, so the variables specifically cannot have negative exponents. For example, x to the negative 2. The variable cannot be in the denominator. Cannot not have. The variables cannot be in the denominator in the bottom. Denominator. Okay, example 1 over x cubed. And it cannot be a square root function. Cannot be a square root term. So square root of x. Okay, so it has to follow the general rules of knots. Cannot be these things. Okay, so the big exponent we have is the leading term. Okay, so the leading term has the biggest exponent we have for the polynomial. So x squared, the biggest exponent is x squared. And we like to write them in the numeric order. So for example, if you had 3x plus 4x cubed plus 4x minus 1, we generally want to write it 4x squared minus 1. We generally want to write it so that we write it in order of from greatest to least of the exponents. So this would be 4x cubed plus 4x squared plus 3x minus 1. Okay? And they have names. Okay? Specific ones have names. Let me see if I can paste this. Okay? So here's a good resource that I have. Okay? A second degree polynomial, okay, the degree of a polynomial is the highest exponent. Okay, so for this previous example, this would be a second degree polynomial on, okay, this would be a second degree polynomial. This would be the biggest exponent is cubed, so this would be a third degree polynomial. We also name them by the number of terms. This has 3 terms. Okay, this is a third degree polynomial and it has 4 terms. Okay, second degree polynomial is called a quadratic. Okay, second degree is called a quadratic. Third degree is called a cubic. Okay, fourth degree is called a quartic. Fifth degree is called fifth degree. That's all interesting color. It's called a quintic. Okay. All right, and let's learn these two number of terms. So if you have three terms, let's start with two. A two-term polynomial, x squared minus 9. A two-term is a binomial. And more specifically, this is a quadratic binomial. Okay? A three-term is called a trinomial. Okay, and specifically, this is a cubic trinomial. Okay, cubic because it's to the third power, trinomial because it has three things. Okay, quadratic because it's to the second power, binomial because it has two things. Okay, a monomial, x squared, is a monomial, but it is not considered a polynomial because it's just one thing. It's not two monomials or more, not a polynomial. It's not two or more being added together or subtracted together. So therefore, it is not a polynomial. Okay, so that's that. Let's see, do I want? Okay, and if you ever have a number is called a constant. Whenever we have numbers, we call those constants. Okay, so for example, if you had 5 is a constant monomial. It's not a polynomial, it is a monomial. Alright, so we can do operations with polynomials. We've done some operations with polynomials before. We just did not define them. Okay, operations with polynomials. Let's actually look at the assignment for this. Let's get some inspiration from the assignments, the polynomial assignment. Okay. Okay, we can name these now. Let's just go ahead and use these. All right. So let's go to the next page. Let's go ahead and simplify the polynomials. The polynomial. Alright, so this is being subtracted. Two polynomials being subtracted. The first one is a cubic trinomial. The second one is also the highest degree is to the third power, a cubic trinomial, and you're subtracting them. Look on the first thing, it's just parentheses. The parentheses are simplified according to PEMDAS. There's nothing you can combine. Okay, and there's no sign or number in front of it, so you just copy it down. 5 and drop the parentheses. You don't need it. Okay, on the second one, notice now that you have a negative, distribute the negative. Again, remember, that's like a -1. Negative just changes the sign, or if that doesn't help you, you can always put a 1 right there, and you're just thinking to multiply by a -1. -1 times 6n squared is -6n squared. -1 times -8n cubed is +8n cubed. Negative 1 times positive 4n is negative 4n. Combine like terms. 5n cubed goes with 8n cubed, and together, that's going to give you 13n cubed. Minus 7n squared minus 6n squared. Together that's negative 13n squared. 6n plus 4n. Oh, actually that is a negative 4n. I almost made a mistake. That's negative. Let's redistribute it. This was a negative 4n. So negative 6n minus 4n is positive 2n. Alright, that's your final answer. Second one. Again, parentheses, nothing in front of it, so you just drop the parentheses. Second one, parentheses is a cubic trinomial. Plus does not change anything. It's like times something by 1, positive 1. It doesn't change anything. So you just drop the parentheses. Positive 3p cubed plus 5p squared plus p. Combine like terms. 6p squared, 5p squared will give you 11p squared. I'm done with that. Okay. 4p and positive p together, that's going to give me plus 5p. Negative 7 is by itself, and plus 3p cubed is also by itself. Now I'm going to arrange it in order because it just looks better. So 3p cubed plus 11p squared plus 5p minus 7. Okay. Now let's find more examples. Let's multiply polynomials. Okay. Let's do okay, back to our problems. That's a problem. Alrighty. How do you multiply two binomials? Okay. Before we do that, let's think about something we've already done. How do you multiply a monomial times a binomial? Well, that's the distributive property, 2n plus 6. We learned that on our second set of our series. What if you had 2n squared times 2n plus 3? Okay, 2 times 2 is 4, n squared times n is n cubed. 2 times 3 is 6, tag along the n squared. Okay, so now we have a binomial times a binomial. Okay, you can either do the distributive property, okay, you can also do the FOIL. If you know the FOIL, you can use the FOIL. I prefer this. Take the first number, multiply it to the second parentheses. 1 second. Multiply it. 8n times 4n is 32n squared. 8n times a negative 7 is negative 56n. 7 times 4 is positive 28n. 7 times a negative 7 is negative 49. Okay, combine like terms. The 32n squared is by itself. The n's combine together. I believe that is a negative 28n. And then you have the negative 49. And that is your final answer. Okay. Another way people do this is using what I call the box method. Okay, so you can use a box method if you prefer that. So let's draw our box. And shake that off. Our box. Okay, so let's go ahead and draw my box method. Draw a 2 by 2 box because you have a 2 by 2, 2 term by 2 term. In front of the box, your first one, 8n plus 7, positive 7. Second one is 4n, negative 7. Multiply inside the box. So inside the box, I'm going to do 4 times 8 is 32, and times n is n squared. 8 times negative 7 is negative 56n. 4 times 7 goes right here, 28, and 7 times negative 7 is negative 49. Combine like terms, these combined across to give you negative 28n. And then the rest of it you can tag along, 32n squared minus 49. Okay, so you don't need to do both methods. You want to use whichever method you prefer. Okay, so you can do the box method or you can do the arrow method, is what I call this. Arrow method, box method. Okay. Okay, so it's up to you which one you choose. And you can, if you know foil, go ahead and do foil. I just prefer my arrow because it helps me organize better than the foil. So I just do first times the 2, second times the 2, and I'm done. Okay, so let's go to the next problem. Now we have a binomial times a trinomial. Okay, so I will do box method first. Draw my box. Now I have a 2 by 3. Okay, and a 2 by 3. Okay, so some people like this because it helps them organize. So again, it's whatever you prefer. So you have 4b negative 8, and then up here you have 8b squared plus positive 2b negative 7. Okay, different color. Okay, 8 times 4 is 32, b times b squared is b cubed. 4 times 2 goes here, 8b squared. 4 times negative 7 is negative 28b. 8 times 8, negative 8 is negative 64b squared. 2 times a negative 8, negative 16b. Negative 8 times negative 7 is 56. Notice how the like terms are in diagonals, so across each other like that. So 32b cubed is by itself. So I'm going to write the answer here, 32b cubed. Okay, I'm done with that. These two go together. Negative 64 minus 8, negative 56. Remember, you do have a calculator, so you can use that. Negative 16 minus 28 will give you a negative number. 6 plus 8 is 14, so it looks like this is 44b. Okay, plus 56, and this is your final answer. You could also use the arrow method for this. Okay, so let me use the arrow method. So this is the box method. Again, it's whatever you prefer. Arrow method, let me copy down my problem. Arrow, right? Or arrow. Alright, no, it's arrow. So, 4b minus 8 times 8b squared plus 2b minus 7 Distribute the first times all of the next one. Okay, so 4 times 8, 32v cubed. 4v times 2v plus 8v squared. 4v times negative 7 is negative 28v. Okay, I'm out of room, so I'm going to write the rest on the bottom, which will help me line it up as well. Negative 8 times 8 is negative 64v squared. Negative 8 times 2 is negative 16v. Negative 8 times negative 7 is positive 56. Okay, combine like terms. 32v cubed minus 56v squared minus 44v plus 56. So again, it's whatever you could prepare. Okay, so here's my challenge. Use whatever method you like and go ahead and do this 3 by 3 box. So you're going to have to do 3 by 3 and combine like terms. Okay, so I'll set up the box. I'll let you do it by yourself. Okay, if you follow whatever method you prefer and you follow what I do, I'm pretty confident that you can do this by yourself. If you want to use the arrow, you can also do that. First, okay, and then you can do second times all 3, and then last times all 3. Okay, and then last times all 3. This times that, by that. Enjoy! Okay, let me make sure I covered everything on this, on the polynomials. And I did. Excellent. Thank you so much for being with me on this. Keep what you're doing, keep working hard, keep doing the problems, keep watching the video. I know that you will do well. Thank you again.